Welcome to OCP's Virtual Summit. My name is Lester Bird from Juniper Networks. The session today is Modular Chassis, MPLS, and MACsec integration on SONiC. We will be demonstrating some brand new SONiC features on Juniper's newest modular chassis, the PTX 10008. Please note the following disclaimer. This presentation reflects current views, but directions may change in the future. Our goal at Juniper is to make SONiC ubiquitous. We want SONiC to be everywhere, in the data center, in the WAN core. To do this, SONiC must support new platform architectures like a modular chassis. It must provide new switch features like MPLS and MACsec. And it must compete with native NOSes. Juniper has three platforms that run SONiC. The QFX 5200, which we see as a Tor, the QFX 5210, which we see as a leaf, and the PTX 10008, a modular chassis that we see in the spine or WAN core roles. The QFX 5200 and 5210 have Broadcom ASICs. The PTX 10008 has a custom ASIC called the BT. It is partially open because we have a proprietary Juniper HAL that simplifies the management of the modular chassis. So why a modular chassis? Well, first, modular chassis exist today, so there's no reason that SONiC shouldn't have one. Some of the reasons for a modular chassis include they are widely deployed in data centers already. They have high WAN port density, a large number of ports. There's a known power consumption. There's a known rack space. One of the characteristics of a modular chassis are field replaceable units or hot swappable devices. And they support high-speed interfaces like 100G and 400G. Today, there are two options for SONiC on a modular chassis. The first is disaggregated SONiC in a chassis. In this case, the entire system is managed as a SONiC cluster. Each line card runs a SONiC instance, so there are multiple SONiC instances. There is a software switch fabric that passes Ethernet frames between line cards. If there is any through support, there's limited through support, typically line cards. Bringing down a line card means bringing down an entire SONiC node. You are bringing down one node in the cluster. At Juniper, for the PTX 10008, we chose a different approach. The system is managed as a single node in a traditional modular chassis way. As such, there's only one single SONiC instance. None of the line cards run SONiC, as they are all managed by the Juniper HAL. We have a hardware switch fabric that passes cells between line cards. We have complete through support for fans, line cards, and power supplies. Pulling out a line card means only those associated WAN ports disappear, not the entire node. We believe this to be superior because it takes advantage of the hardware switch fabric. It has simplified management, and because a single IP address is associated with the node, there are reduced routing adjacencies, leading to better scalability. Here is a diagram illustrating disaggregated SONiC in a chassis. As you can see, there are multiple SONiC instances that comprise the cluster. BGP, EVPN, and VXLAN handle control plane distribution as well as the software fabric. Contrast that with the Juniper PTX 10008 with a single route instance, a hardware switch fabric that interconnects all the line cards. In this case, none of the line cards run SONiC. We use Juniper's Advanced Forwarding Toolkit, or AFT, to distribute routes across the line cards. AFT is part of the Juniper HAL. Field replaceable units are a key characteristic of a modular chassis. This complicates SONiC a little bit. Since SONiC typically assumes static configurations, we had to extend SONiC to handle a more dynamic behavior. With throughs or hot swappable devices, line cards and their ports may be removed or installed after SONiC boot. They may be inserted into a different slot. Fan and power supplies may be removed without affecting system uptime. The result is a very dynamic changing system. Therefore, we had to extend show environment to reflect the current system state. The default SONiC interface naming scheme was also problematic. As we said, line cards could change slots during system uptime. Names like Ethernet 0, Ethernet 1, they fail to indicate port locations, and this is problematic for the administrator if a port has problems. Our solution is to embed slot and port numbers into a dynamically generated SONiC port name. Juniper is proud to be the first to offer MPLS on SONiC. We had to overcome a few issues. First, SONiC does not currently support OSPF and ISIS, the typical label sources for MPLS. Consequently, we must have an external SDN controller as the MPLS label source. Right now, we support basic MPLS operations, namely push, pop, and swap. To integrate MPLS into SONiC, We had to add new MPLS tables to Redis and modify the SONiC daemons to act on those tables. As the SDN controller, we use Juniper Northstar or some other suitable SDN controller. We leverage CRPD, Juniper's containerized routing protocol suite, to inject MPLS routes into the Linux kernel. And of course, we will upstream MPLS changes to the SONiC open source community. The second new SONiC feature that we will demonstrate is MACsec with MKA. There is a new MACsec side proposal, but if you read it, you'll discover that it covers data plane operations only. We still need MKA for the control plane, and MKA must be extended with XPN to support 100G and 400G interfaces often found on a modular chassis. Like MPLS, to integrate MACsec, we had to add tables to Redis and modify the SONiC daemons accordingly. For MKA, we use open source WPA supplicant. We have added XPN, extended packet numbering, to WPA supplicant to handle high-speed interfaces. And again, we will upstream MACsec and WPA supplicant to the community. We now have a short video demonstrating MPLS, MACsec, and MKA on Juniper's PTX 10008 modular chassis. Hey everybody, I'm Lester Bird. We have some exciting new innovations to talk about. Juniper has added MPLS and MACsec to SONiC. We are using Juniper's newest 400G modular chassis, the PTX 10008. Let's talk about MPLS first. This is our test topology. We're using an SDN controller to generate MPLS routes. We also have a couple of IXIA ports to generate MPLS traffic. This is the MPLS programming sequence. The SDN controller uses HTTPS to talk to an agent running on the PTX 10008. The agent uses the Juniper extension toolkit to talk to CRPD, Juniper's advanced routing stack. CRPD adds the routes to the Linux kernel. It publishes to Redis, where syncd picks up the publication. syncd calls Psi to program the PFE's fib. Let's go to the console and execute some commands. From this screen, we see that the agent has received 140 MPLS routes from the controller, and CRPD has programmed all of them. We see the push, pop, and swap routes. Using the standard IP route command, we can verify that CRPD has installed the MPLS routes into the Linux kernel. To make MPLS work with SONiC, we had to add a few Redis tables. We show them here briefly. As might be expected, there's also MPLS information in the ASIC DB. We now verify that the routes have been programmed from SONiC to the PFE fib. Lastly, we confirm that the PTX 10008 is doing the MPLS work like we expect. We bring up Wireshark and look at the packet decode. Here we see a MPLS packet. This is an MPLS swap. That's MPLS in a nutshell. Let's take a look at MACsec now. This is our test topology. But before I get too far, I want to tell you something that's exceptionally noteworthy. The PTX 10008 can do 400G line rate MACsec. Isn't that awesome? I'm working on a video for it, so keep a lookout. For now, we'll show you how we integrated MACsec into SONiC using a much simpler topology. Let's type some commands. First, note that we've added a new MACsec stanza to configdb.json. We've also added a new MKA Docker container. The main process in this Docker container is open source WPA supplicant. We've added XPN to WPA supplicant to handle 100G and 400G interfaces. WPA CLI allows you to look at current MACsec information. Finally, we ping between the PTX 10008 and the Linux server, the MACsec peer. As you see, ping is successful. An interesting experiment happens when we kill WPA supplicant on one side of the MACsec tunnel, in this case the peer. When we kill WPA supplicant, ping stops. When we restart WPA supplicant, ping resumes as expected. We can also look at MACsec activity by examining the normal SONiC logs. In closing, Juniper has added some fantastic new SONiC features. We will upstream MPLS and MACsec changes to the SONiC community, so please look forward to them. We invite you to come by and talk to us at the Juniper booth. Thanks for your time, and talk to you soon. That was our video. As I mentioned, we plan to give back many of these changes to the SONiC community. These include MPLS, MACsec, MKA with XPN, through insertion and removal, dynamic interface naming, and corresponding Ansible test scripts to test this new functionality. All these new features will be available eventually in SONiC open source release code. We are currently formalizing upstream plans. As we wrap up, SONiC on the PTX 10008 will be available later this year in 2020. For information on CRPD, Juniper's routing protocol suite, I refer you to the following URLs. That's a quick summary of MPLS and MACsec on a modular chassis running SONiC. At this time, I would like to invite online questions, or if you prefer, you can send me email. Thank you very much for your time. Have a great day.
Hi everyone. So I'll answer your questions as you have them. There's one question here: would Juniper also contribute to PyTest as we are moving away from Ansible test to PyTest? Yes, we will include PyTest as we update scripts. Upstream, another question: are the upstreams already available? No, we're working on that. We hope to do that as soon as feasibly possible as we prepare our systems for release. Nope. Does CRPD require MPLS for it to work in SONiC? We leveraged does MPLS require CRPD for it to work in SONiC? We leveraged CRPD because it made programming of MPLS routes. It is not, you don't have to have CRPD, but you have to have a way to put MPLS routes into the kernel. After that, then the new changes will take over. Oh, XPN. What is XPN? XPN is extended packet numbering, and it's to prevent wraparound on high-speed links like 100G and 400G. Otherwise, you're going to do a lot of control plane chatter between the ASIC to handle the wraparound case. So the MPLS performance is going to be the same as the ASIC, right? Once you program it, the ASIC is taking over. So the question was, how is MPLS performance? So it'll be at the same rate the ASIC is capable of handling it. Oh, dynamic. So there's a question: what is dynamic interface naming? Dynamic interface naming has to do with through insertion and removal, where you can remove WAN ports. You can pull out cards because they're hot swappable. And so after you boot SONiC while it's running, you could replace WAN you can replace line cards, and so you no longer do static configuration like portconfig.ini. You have to say what is the current system inventory and what are the ports that are installed. It's very possible that you installed a card after SONiC was boot, and they're not going to be in any configuration file. So dynamic interface naming is recognizing them as they come live and making them available to the SONiC system. What is apt and what does apt fit in SONiC? SONiC doesn't know that it's using apt. It's a part of the Juniper HAL. apt is Juniper's advanced forwarding toolkit used to help program multiple ASICs. Let's see. So the question is, does SONiC use apt? SONiC itself does not use apt, but on our platforms, our Juniper platforms, where especially our multi-PFE platforms, we have a Juniper HAL. apt is linked into that Juniper HAL to program multiple PFEs, multiple ASICs at once. So on our system, SONiC will call into a Juniper HAL, and that Juniper HAL does require apt. On other SONiC systems from other vendors, apt won't be involved. Right. So SONiC, as part of our SI interface, as part of our backend, SONiC does have SI. SyncD will still call SI. SI will call into our Juniper HAL instead of an SDK library meant for the ASIC. That Juniper HAL will handle programming multiple ASICs. So the Juniper HAL is our backend for SI. So if you have any more questions, please free to type them in. And if you come up with questions later, you can always send me an email or a V-card, and I'll get back to you. It looks like we're not getting a whole lot more questions, so. So with that said, again, I encourage you to send me an email if you have questions to follow up. I wish you all a great OCP and a great weekend.